I want to find the differential dy for the function y equals x cubed minus 3 times the square root of x. So I'm going to be taking the derivative with respect to x. So the derivative of y with respect to x is dy over dx, and the derivative of x cubed is 3x squared. We can rewrite 3 square root of x as 3 times x to the 1/2 power. So if I use the power rule, I get 3/2 times x to the negative 1/2 power. My goal here is to solve for dy, so I'm going to multiply both sides by dx. So the dx are going to cancel. I'm left with dy, and here I can factor out a 3, so I have 3, and then I can also factor out an x, but I have the option of factoring out an x squared or an x to the negative 1/2 power. And here it makes sense to always factor the smaller one, which would be negative 1/2. And that leaves me with x to the, 5/2 minus 1/2 times dx. So this is what dy is equal to. Next, I have y equals x times the square root of 1 minus x squared. I can rewrite this as x times the quantity 1 minus x squared raised to the 1/2 power. And here I can take the derivative with respect to x. So I'm left with dy over dx. I have to use the product rule first and then the chain rule. So the derivative of x is 1. And then times 1 minus x squared to the 1/2 power, plus I want to take the derivative of 1 minus x squared to the 1/2 power. So I'm going to bring down the exponent, keep the inside the same, subtract 1 in the exponent, and then multiply by the derivative of the inside. So this whole thing is the derivative of 1 minus x squared to the 1/2 power. And then I'm going to multiply it by x. A couple things cancel, so I have the two's canceling here. And now I see that I have 1 minus x squared, 1 minus x squared. So I can pull that out. But I always want to pull the one with the smaller exponent. In this case, negative 1/2. So what's going to be inside is 1 minus x squared. And then here, I have minus x times x will give me minus x squared. And on the left, so I have dy over dx on the left. I can choose to multiply both sides by dx. So I'm going to have dy by itself. And because I factored these two terms out like this, I have it in two factored form. So I could just put the dx at the end here. And finally, I can simplify. I get negative x squared minus x squared. That'll just be negative 2x squared. And that's going to be my dy. So this whole thing. And if you want, you can bring the 1 minus x squared on the bottom as a square root like this. Okay. And that's dy. All right, next we have y equals 2x over 1 plus x squared. Here I'm going to use the quotient rule. So the derivative of y, equals. For the quotient rule, it's good practice to always start with the denominator squared. And now we're going to take the derivative of the top, which is 2, times the bottom, minus the derivative of the bottom times the top. So just to get this out of the way, I'm going to multiply both sides by dx. So I'm going to have a dy left. I'm going to distribute out the 2. So I'm going to have 2 plus 2x squared minus 2x times 2x is 4x squared over 1 plus x squared squared. Then I'm going to have the dx left over. So dy, and then 2x squared minus 4x squared is 2x squared. And that's going to be 1 plus x squared squared. And this is good enough. I cannot simplify the bottom. So the reason I cannot is because I have 2 times 1 minus x squared at the top, which is 2 times 1 minus x, 1 plus x. And I can't simplify the 1 over x squared with any of the factors at the top. So this is just a wasted effort. And we can just end with what we had previously. All right. So we have y equals 2 times the square root of x over 3 times the quantity 1 plus square root of x. Okay, so for this one, we're going to have to use the quotient rule. And I see there's square root of x twice. So I'm going to, on the side here, let's take the derivative of square root of x. Well, square root of x can be rewritten as x to the 1/2 power. And by using power rule, I get 1/2 x to the negative 1/2 power, which can be rewritten as 1 over 2 times square root of x. So I'm going to use this shortcut here. So I'm going to use the 1 over 2 square root of x whenever I'm taking the derivative of x, just to save time and space. Okay, now I'm going to start my derivative. So I have the derivative of y with respect to x. And because we're doing the quotient rule, put the denominator squared first. Okay, then we're going to take the derivative of the top. So that we're going to have 2, and then multiply by the derivative of square root of x. So that would be 1/2 times 1 over square root of x. Okay, so that's the derivative of the top times the bottom. Okay, minus the derivative of the bottom. So I can factor out the 3, and then take the derivative of 1, which is 0, times the derivative of square root of x, which is 1 over 2 square root of x, times 2 square root of x. Okay, now the 2's will cancel. The 2 square root of x will cancel. Okay, so I have 1 over square root of x times 3 times quantity 1 plus square root of x minus 3 all over. So the square here is going to go on the 3 and what's in parentheses. So it's going to be 9 and then 1 plus square root of x squared. I'm going to distribute the 1 over square root of x to both of these. Or actually, yeah, let's just do that. So that'd be 3 over square root of x. And then, well, it might be better to distribute this all at once. So that would be plus 1 over square root of x times 3 square root of x minus 3 all over 9 times 1 plus square root of x squared. And we see that the square root of x's are going to cancel here. So I'm left with 3, and then I have a minus 3 here, so that's going to be gone. This 3 and 9 are going to simplify, so that's going to be 1, and this is going to be 3. And I have a square root of x on the bottom here, so we'll just store it over here. So really, the top is only going to have 1 left, and the bottom I'm going to have 3 square root of x times the quantity 1 plus square root of x squared. So keep in mind, I didn't write this out, but this was dy over dx here on the left. So I would have multiplied both sides by dx, so that's going to go away. So I'm going to be left with dy on the left, and that is my final answer.